Hey guys, today I'm going to be covering all of Chapter 1, Section A of natural hazards. So what is a natural hazard? A natural hazard is a natural event that causes harm to human life or poses risk or danger to it. There are four categories. One is geomorphological. Geomorphological events occur on the Earth's surface and they cause, for example, flooding. Secondly, we have biological. Biological, they involved living organisms, for example, forest fires. Thirdly, we have tectonic hazards. Tectonic hazards involve the movement of tectonic plates, for example, earthquakes. Fourthly, we have atmospheric. Atmospheric involve the Earth's atmosphere. For example, we have hurricanes. So, what factors affect hazard risk? Well, we have deforestation and urbanization, as well as the population, day and time, and where or when it occurred. So, distribution of earthquakes and volcanoes. Well, we have the convectional current. A convectional current is basically hot air rising and falling in the mantle, and this causes the plates to move. The plate margins are where two plates meet. We have slab pull, which is we have slab pull, which is basically subduction, a ridge push, which is pulling them apart. For example, in constructive plate margins. We have many layers to the Earth. For example, we have the outer core. We have the crust first, which is obviously solid and is split. The crust is split into tectonic plates. Then we have the mantle, where convection currents is made of liquid. Then we have the outer core, again that's liquid, and have the inner core, which is solid, liquid, and iron. We have three types of volcanoes: dormant, extinct, and active. For example, in Japan. Then the volcanoes and earthquakes all occur around the plate margins, and they occur in a linear belt. Linear belt is like a chain, and example of these are the Ring of Fire in the Pacific. And we have hotspot. Hotspots are where magma doesn't fully rise to the crust. Constructive plate margins. Constructive, I like to think of this as smart, so they move away from each other. Magma rises through the gap, and they form new land. After various eruptions, this forms a shield volcano. Shield volcanoes are gentle sloped and wide. They also form ridges and rifts, for example, the Mid-Atlantic Ridge. Destructive plate margins. Destructive plate margins are where two plates are moving towards each other. If it's too continental, then they push upwards and they form fold mountains. If it's oceanic, then slab pull occurs. Oceanic plate is more denser than the continental one as they move towards each other. So the oceanic plate subducts the continental one, and this can cause an earthquake. And it can also cause an oceanic trench at the zone of the subduction of the oceanic plate. Due to high friction causes the mantle to melt, and this means magma rises through the gap via the magma chamber or the volcanic vent, or whatever you like to call it. This comes out as lava. This forms strata or composite volcanoes, and these are like made of layers of volcanic ash, tephra, and proslactic flows. Conservative plate margins are where they're sliding past each other. So as they slide past two continental plates, as they slide past each other, huge amounts of friction is created. And when that friction is finally released, it's released as a jolt. That jolt is an earthquake. How are earthquakes measured? Well, they're measured using a Richter scale, which is varying from 1 to 10, 10 being the largest, 1 being the lowest scale. So why do people choose to live near volcanoes? Number 1, geothermal energy, which is a source of renewable energy, particularly locational to volcanoes. Number 2, friends and family. People feel emotionally connected to the place they don't want to leave. Number 3, farming. After volcanic eruption, lava leaves behind very fertile soil which can be used to grow crops. Number 4, mining. Mining, obviously, for example, sulfur and other extractions can be used to make matches. High wages also available. And last but not least, number 5, tourism. Tourism can provide jobs for breadwinners and is very useful. How can we plan and protect and predict? Well, predictions, we could use computers, and we can measure foreshocks, for example, using seismometers. For monitoring of earthquakes, we could use seismometers. For monitoring of volcanoes, we could use titometers. We can also measure the sulfur gases or the surface water temperature. For earthquakes, we could use animals as well as technology. Technology can sometimes be unreliable. We can use we could use the technology for shocks, or even aftershocks after an earthquake. We could for protection, we can have earthquake-proof buildings which have reinforcement poles which sway with the wind direction. We also have the hollow bricks, shatterproof glass, launch pads, and a special identification number for quick rescue. However, for volcanoes, we cannot protect because we don't have anything against the lavas and porostatic flows and the gases. However, we can take precaution. For example, we can have earthquake drills and volcanic drills. We can have evacuation zones, nowhere to go, or emergency supplies. We can fasten furniture. We can be educated about what to do. For example, crouch down low to prevent, or wear masks to prevent the gases, inhaling gases and suffering from suffocation. So that was the first section of tectonic hazards.